The topic of this lesson is what can you assign to a pointer and how. For this lesson, we are only going to consider three things. Single variables of a given data type, like integers, characters, double quoted strings, and single quoted characters. A major part of mastering C is being able to clearly understand exactly which things are going to be treated as if they were memory addresses and which things are going to be treated according to their actual value. Let's say, for example, I write this. Now, we know that we're creating a variable called I. We know that I resides at some memory address. The question is, if I want to specify that I want to work with I's memory address, do I need to say ampersand I, or do I need to just say I? The first rule of thumb that you need to remember here is that whenever you are working with a single variable of one of the basic data types like integer, character, and so on, then anytime you use that in your program, it is using the actual value of that variable. So if I write, for example, what C is going to do here is it's going to create an integer called j, and it is going to assign j the value of the variable I plus 1. Notice that there is no dereferencing going on here. There's no memory address operation going on here because this is a single variable of one of the basic data types. So C understands that we want the actual value, in this case 5. So to be clear, anytime that you are working with a single variable of one of the basic data types, character, integer, and so on, then whenever you write that variable in your C program, it is not being treated as if it is a memory address. It is being treated as the actual value. So again, if I write j equals I plus 1, then this is not thought of as a memory address. We're not adding 1 to a memory address. We're adding 1 to the variable itself, what is at that memory address in this case. Now the same is true for characters. If I write this, for example, then later on in the program, if I write something like this, this is being interpreted as the value, in this case A. It's not being interpreted as the memory address. Why? Because it is a single variable of one of the basic data types. And that means it can fit inside of a space that is small enough that you don't need a memory address in order to work with it. And that's the key point. So for example, here I have 3 lines of code. All 3 lines of code are variables, and therefore none of these are treated as if they were memory addresses. All of these single variables of a given data type will never be seen by C to be a memory address because they are small enough that they can all be processed as is. That means that you can never directly assign one of these to a pointer. For example, you can never write this code. So take a look at what we're doing here. We're saying we're creating a character variable called SomeCharacter. We're assigning it the value of the character Z. That's fine. This code is fine. And then what we're doing is we're creating a pointer called myPointer of data type char. This highlighted part is fine. But then what we're trying to do is we're saying that this pointer is equal to SomeCharacter. That is not fine. What we're doing here is we're treating the value Z as if it was a memory address. So you don't do that. Here you must use an ampersand to get the address of. If you don't use the ampersand, then what you're doing is you're trying to assign the character Z as if it was a memory address. Now how do you know? You know because SomeCharacter is a variable of one of the basic data types. It's not an array, it's just a single variable of data type char. So that's how you know that you can't directly assign it to a pointer. You must use an ampersand character, and that's one of the main points of this lesson, is for you to understand when you use the ampersand and when you don't. So again, if it's a single variable of a given data type, any of these, anything that falls into category 1, you must use an ampersand. C will not automatically treat it as if it is a memory address in your program. So the correct way is like this. Again, we're creating the variable some character. We're giving it a value, which is the character Z. And here we are creating a pointer called myPointer, and we are giving it the value, which is the memory address of that single variable. Now let's go ahead and discuss double-quoted strings of text. Now before we do, remember that a double-quoted string of text is always equal to each character of the string, one after the other, followed by a null termination character. You cannot, for example, write this. Because this is a double-quoted string, you're not saying a single character H. You're effectively saying H followed by the null termination character. So if you want a single character, you must use single quotes. There's a very large difference between using single quotes and double quotes. In single quotes, you're getting a single value, which is, for example, if we were to write this, then it's the same thing as if in binary we had written this, which is of course 0x61, which is the character A. Now on the other hand, if you were to write this, then you're actually doing something much more complex. You're finding a location in memory, you're storing A followed by the null termination character at that memory address, which means this is a memory address, which means it needs to be assigned to a pointer, not to a character variable. So this entire line of code is wrong for that reason. We would do this instead. So whenever you have a double-quoted memory address in C, anywhere, if I write, for example, this, for example, what happens is C is going to take this double-quoted string and it's going to put it somewhere in memory. And then, in effect, what's happening is anywhere that you've used that string of text in your program, it's actually going to be getting the memory address of that string. So that's how the printf function sees this. And as long as you send a memory address to the string hello, then what you'll get is the output hello from that printf statement. So anytime that you see a double-quoted string of text in C, it is treated as a memory address. Specifically, it's treated as the memory address to the first character of that double-quoted string. So unlike variables that we talked about, unlike the single variables of a basic data type, double-quoted strings are treated as memory address, and therefore you would never write something like this. That is totally redundant. You're saying, what is the memory address of this, which is itself a memory address, and that does not make sense in this context. You only need to write this in order to have that effect. So if, for example, we create a pointer, now we want to assign that pointer a value, we can just write this. Now, this is a memory address. It is the memory address to where this string of text is located, and so this is entirely valid code. You would never write this because it is unnecessary. Now, on the other hand, if we had made this a variable string, and let's do this. Let's say we create two variables. We'll call this myChar, other char. So let's assign myChar equal to the value of the single character A. And then here, if we want to set, let's make this into a pointer. If we want to set this pointer to be equal to that memory address, we would write this. Like that. Now notice what we would not do. We would not, for example, do this. That would be entirely wrong. Remember, this is an actual value. It's the value of 61 in hexadecimal. it's stored in a single byte. It doesn't require a pointer or a memory address. We can just use that value wherever we want it. So you would never put an ampersand in front of a single quoted character or in front of a double quoted string. You would never do that. However, whenever you're working with a single variable of one of the basic data types like here, then you must put the ampersand character. So let's go ahead and review the main points. First of all, for single variables of a given data type like int, char, and so on, if you want to assign their memory address to a pointer, you must use the ampersand character. For double quoted strings, you cannot use the ampersand character, and you do not need to, because C understands these as having a memory address already. Therefore, you can assign a double quoted string directly to a pointer, or you can use a double quoted string anywhere that a pointer to a string of text is expected, or in fact anywhere that a pointer to a character is expected. This means that to set the pointer equal to the memory address where the string begins, all you need to do is just put the string of text itself. This will be treated as the memory address, and more specifically, it will be treated as a char pointer. And lastly, when you're talking about single quoted characters, like this for example, as far as C is concerned, these are no different than numbers. You would not say the memory address of the number 5, for example. Similarly, you would not say the memory address of a single character, such as the character A. In other words, you would never write something like this. To further illustrate that last point, take a look at this. So if we create a character called myChar and we give it the value of the character A, then myChar is a variable that is stored in memory, and if we want that memory address, then we must use the ampersand followed by the variable name, whereas the character A is just a character. It has no memory address. It's not even stored in memory. When you write this in your program, it would be the same thing as if you had just written this. It's just going to be treated as an actual number. C doesn't even need to store it anywhere in memory. Alright, that concludes this lesson. In the next lesson we'll continue our review of pointers.